So do a countdown. 18. Okay, here's the scenario. You just inherited security responsibility for one of the largest applications in your company. It's a big beast, it's ugly, it's never gone through any security due diligence before. So being a good practitioner, you decide source code review, threat modeling, and results are less than encouraging. There's SQL injection, cross-site scripting, a little bit of XML injection, authorization being done on the client but not the server. So you take a deep breath. And you ask yourself the million-dollar question. What do you do now? So, this is an open question to the audience. What would you do? If anyone's been in a scenario like this, you just got an application, just reviewed it, it's terrible, it's been around for a long time, it's critical, what would you do? Rewrite, refactor, okay, anything else?
Request for fun.
What's that? Redesign, You could use dependency injection, for those familiar with the Spring Framework. There's a lot of things you can do. But typically you're going to come up with things like refactoring, right? And that's going to be expensive. So we're here to talk about another way of doing that. So welcome everybody to AOP and Security. My name is Rohit Sethi. I work for Security Compass. And this is Nish Bhalla.
Hi everybody. My name is Nish Bhalla. I'm with Security Compass, and we are going to talk about AOP and different ways of using AOP to help prevent various types of attacks that Rohit was just introducing you to.
Okay, and for those of you who don't know Security Compass, basically we're a company that specializes in application security. We do consulting and we do training around this area, but this is our bread and butter. Okay, I need a volunteer. We have bribery. I know we don't have beer, I'm sorry, but
All right.
a Twix bar? We have one, okay.
All right.
You can come up. Hey, what's your name?
Frank.
Frank. Please everyone welcome Frank. Okay. Despite what you think, Nish is an object, and Frank is an object.
Already objectifying us.
They're instances of the person class, okay? Nish has this method called throw, where he has a parameter ball, and Frank has a method called catch, where he's going to catch the parameter ball, like so. Excellent, no exceptions. And then there's a return. Okay, that's great, everything worked as normal. Now I'm going to show you something slightly different. I'm Rohit the aspect.
So again, I'm going to throw the ball.
But I catch it. Frank doesn't know that I caught it. Nish doesn't know that I caught it. I look at the ball, and I say, this is funky, it's green. Didn't expect it to be green. Has a bunch of writing on it. Malicious characters. Malicious characters on this parameter. So I'm going to throw an injection and exception, and that's it. It's gone. And that's the idea, fundamental idea behind aspect-oriented programming. And we're going to get a little more into it. But please thank Frank again.
So we just saw that I was an object, Frank was an object. I made a call to Frank, Frank received it, and he passed it back to me. That's basically traditional, object-oriented, right? What we also saw was, in the middle, Rohit came in and he was the aspect. The aspect actually stopped the call before it reached the second object, looked at it, it does an analysis, and on the basis of the analysis decides whether it should allow this transaction to go forward or it should stop and drop the transaction or return it back to the parent object or the callee itself. Okay? Think of aspect as pretty much like a proxy, if you will, when you're doing web pen testing, right? You have a proxy that sits in the middle. The browser doesn't really know about it. The server really doesn't know about it. You let the transaction go through. At the proxy level, you can either modify it, you can allow it through, or drop the transaction. However, this is at runtime, so it's more like a runtime debugger, which is constantly monitoring for a particular transaction to go through, and if that transaction goes through, then it actually will look at it, examine it, see if a particular action should take place. If it should, it modifies it. If it should not, then it returns it back to the object, parent object itself.
Okay, so you're all thinking this is a bunch of theory, what's going on. So let's see this really happen in real code, okay? This is Daffodil CRM. It is a great application because it's vulnerable to everything under the sun. It's open source and it's Java. Okay. Now, in the talk of CRM, for people who are not familiar with it, it's customer relationship management. We have this great idea of a lead, okay, which is a sales lead. So what we're going to do is we're going to go into Daffodil CRM and we're going to enter a couple of leads. So we'll enter one called test. Everything is great. Let's try one with, after test, something a little more malicious maybe. Script something, right? Submit. Now we're going to go back and take a look at all of the leads that we have. Okay, so we refresh. And boom. Okay, cross-site scripting, so not a major vulnerability, right? Just a stupid little pop-up box that doesn't mean anything.
I think that's true. What do you guys think? Yes, but it's persistent as well. It is persistent. You can steal cookies, yes. I guess many of you might have seen it on OWASP as well. OWASP rates cross-site scripting as the most prevalent attack vector in web applications. I guess more than, 70–80% of applications on the internet are supposed to be vulnerable to this. What can you really do with this, Rohit?
Well, if any of you have seen some of the kind of latest research that's going out with, combined with cross-site request forgery and with AJAX, we can do a lot. Right? In online banking, you can steal funds with just a single cross-site scripting anywhere in the application. Over here, we could probably steal information for every client who's in the CRM. Okay? So you can do a lot of damage with just a single cross-site scripting vulnerability. But that's not the focus of today's talk. So let's look a little bit further. Okay, we're going to delete those leads. And we're going to go back to look at the actual source code. All right? This is Eclipse IDE. That's the integrated development environment. How many people have done some sort of development with Java or .NET here? Okay, so for you guys, this is probably look familiar. For everyone else, just stick with us. It's not going to be too crazy. So we're going to actually look at the source code for what we just saw. So over here, we are going to look for a particular class called the new lead bean. New lead bean, if you're familiar with Java syntax, basically is a bean which corresponds to the object we were looking at, which was a new lead. And it has a bunch of variables that you can access with getter or setter methods, get something or set something. So one way we can enforce input validation is anytime you set one of the variables, we can do input validation there. We can do whitelist validation or blacklist validation, right? Again, nothing revolutionary in that concept. So we're going to look particularly at set name. That's the thing that we want to protect, but we're going to do it without changing any of the existing source files. So 3 steps to convert something to an AspectJ application. Number 1, download the AspectJ toolkit for Eclipse. Number 2, right-click on the project and say Convert to AspectJ. And number 3, we need to copy one runtime library, just like a DLL, right, into our compilation path, which is what we're doing here, AspectJ RT. We throw it into our WebINF. And that's it. We have an AspectJ application, okay? That's all it takes to convert from your regular Java app to an AspectJ app. And it's just as easy to go back. And that's the key here. You don't like it, you go back. You simply remove any AspectJ stuff, you remove the jar file, you right-click on it and say Convert back to Java. Okay, so we've done that. Now we're going to do something called creating an aspect. An aspect is a lot like an object. So we're going to just do the same thing as we would normally do in Eclipse. We're going to say new, but instead of a class, we create an aspect. And that aspect's going to have a package, just like a class has a package. That aspect's going to have a name, just like a class has a name. Okay, that aspect can have fields and methods, just like a class does. And we're going to hit Finish. And there it is, very simple and straightforward. So we've already created a more complicated one. I'm going to copy and paste that in. This is the input validator aspect. At a high level, we're going to take some kind of input, we're going to match it against this regular expression, do whitelist validation, and if there's an issue, we're going to throw an illegal argument exception. Okay? That's what we want to do with this aspect. Notice you have the class or aspect name, you have private variables just like normal, but you have a few other kind of funky things, and we'll talk about that in a sec. So the first one we're going to look at is a point cut. The point cut, remember my example where I was the aspect? Point cut says where in the program execution we're going to change the flow. We're going to inspect things. So I was doing before Frank caught the ball. Basically before person.catch executed, I looked at the ball and I rejected it. Okay? That's a point cut. And you can basically change that at any point. You can define a whole bunch of objects that you want to point cut on, or you can say just one. So over here, what we're saying is, on the execution of the new lead object, and notice the star. That star is the return type. Okay, so if we go back here, we know it's void. What we're saying is we don't care about what the return type is. New lead bean is the class, and then we have set star. Well, set name or set campaign type, they all satisfy set star. And then we have string, so we need to have a string argument. So just to clarify, this is telling us how to match, right? What's the return type? What's the class type? We could specify a wildcard in the class type and say every class, or we could say every class from a package. We could say every class that's a subtype of a certain type. And then we have the methods. We could give specific method names, or we could use wildcards for method names. And then we have the arguments. Same deal, okay? We get really kind of a lot of flexibility here. And then we have our argument. Don't worry about the syntax, but what we're saying is this string argument we're going to pass and use later on. Okay? So now we've saved it. The next piece here is our before advice. And what we're saying is before this executes, any of these setter methods, which is string argument, actually execute, we're going to do all of this crap. Okay, so this is whatever, some null checking, and then we're going to do a regular expression check. And if it doesn't match, we throw our exception. And if it does match, everything goes on as if nothing happened. Okay? Notice this little arrow. This is a visualization tool that helps us to tell where things are happening. And that's a very important thing when we come to aspects. We need to know what's happening. So here we have this arrow, and it corresponds to this. Before any of these methods execute, this is going to happen, okay? So it allows us for some traceability. A lot of people think when you look at aspects, it changes the execution of code and you have no idea what's going on. So we have visualization tools to help us with that. So notice then that we also have these little arrows in our original source code saying what they're advised by. Again, we didn't change the actual source code, but the execution will change. Okay, campaign type will also fit that. Now let's go back to the actual application and see it work. Okay, we're going to log in again. This is, by the way, vulnerable to 1 = 1 injection. They never fixed that, but that's a different story. So let's go to the new lead, and let's add the new lead. Okay, same thing as we did before. Script, alert, script. But notice, despite the ugly stack trace that they should never have had in the first place, it's a really bad application. The exception got propagated, and we have application security attack thwarted. So, moral of the story here is that we didn't change the source code, but we were able to stop an application security attack. And we can really extend this to be a very, very powerful concept. So, before I go on, does anyone have any questions on what we just saw? Go. That's true, but that's true for any solution that you have to it, right? You can always miss. The point here is that it's easier to add to it, right? You don't have to change the source code. You can just change the point cut, right?
So 2 quick questions.
Sure.
One, what type of performance hit are you looking at?
Excellent question.
Is there any way to get something a little more elegant than just a nasty stack trace?
Sure. Both good questions. So the stack trace is, by the way, the application was developed, but with, and I'm going to address this one first. What we can do in Aspect-J is we can actually catch exceptions if we wanted to, and we could give a much more elegant return. Of course, what they should have done is they should have defined their web.xml better, but that's a different story. We can catch all of these kinds of vulnerabilities. Performance impact we'll get back to later, okay?
So if your aspect is called from a method that doesn't handle the exception, what happens in those cases?
I'm sorry, say that again?
If your aspects are being called after execution from a method that's not handling the exception, does aspect actually add in that the exception handling?
Yeah. So you're saying if
Say you have an application that just has no exception handling, but just has exception server there.
yeah.
And you add a point cuts on top of it that have aspects with exceptions.
Yes, you can. So in Aspect-J, the question was if you have applications right now where you have methods that are not handling exceptions, can you do that through aspects? And the answer is yes. You can add that functionality in.
Now, is it going to modify the code in the precompile?
It's going to modify the compiler. It's going to you have to use a different compiler, and that's how it works. And that actually comes back down to the performance impact, which we'll talk about later.
Is there certain circumstances where it might just be easier to change the code, like try catch finally instead of like doing with Aspect-J?
Yes, there are some instances where that makes sense. Aspect-J is not the final solution to everything. Sometimes you don't have a chance to modify source code, and what we're going to talk about a little later on is, in some cases, it modularizes in a better way that it makes sense to do it this way. Okay? If there's no more questions, we'll move on.
I have one.
Okay. Nish?
Okay, in this scenario, we were doing set something for name. What if I wanted one setter that should not be part of it? Can we actually handle that?
Yeah, we can basically define arbitrary point cuts. So we can say not this particular method, but all of these other ones. We can get as granular as we want or as kind of wild card as we want. Okay, so just as a quick recap, this is what it looked like. This is all the source code that we have, right? We have the aspect a couple of instance variables. We have our point cut that defines where we're going to inject. We have our advice that tells us what we're going to do. It says before. We could also do after, or we could do around, both before and after. Okay? And we're doing basically your regular expression check along with an exception, throwing an exception if there is a problem. Sorry? The matcher, sorry. Yes, there is a couple of import statements on the top. Apologize for that. That's the Java regular expression matching, regular library. Okay, the authorization check, we can do the same kind of idea. So imagine this, you have an old application that doesn't do authorization checks on the server side. Let's say, for instance, you have a RMI interface, or you have a web services interface, right? You need to control that. So let's say that for that particular interface, you have a whole bunch of public methods exposed from something you call a service object, okay? This is just theoretical, but it applies, right? What we're doing here is we're saying anytime that a service object is executed, for that particular service object, anytime there's a public method that's executed, throw it through the access checker, check the user that's there right now and that object. And if they have correct access rights, then you go on, and if they don't, then you throw an invalid access exception. Okay, so this is another instance of how we could use AOP to fix an application that already exists. So here's a question to you guys. Can you think of any other areas where you could see AOP being used for security? And we have bribery, smaller forms of bribery than before. Snickers, little Snickers.
Actually, I have one. A lot of handheld applications, they're starting to move in this direction. What do you do if you are trying to wrap something where you don't necessarily have the source code to work with?
Excellent, excellent. I think that's an excellent question. I think the question alone deserves a chocolate. What if you don't have the source code alone? That's one of the best parts of AOP, and we're going to show you this again later. But if you have the compiled code, if you have the jars in Java, or you have some kind of library, you can actually use AOP to advise on compiled code. So you don't have to search through source code. Okay? But what are some other applications? So we've talked about input validation, we talked about authorization.
Can you have time and state at all?
Can you affect time and state? You mean like from a concurrency standpoint?
Absolutely, like synchronization issues or anything.
Yeah, so there is a bunch of controls put in for synchronization. Like these aspects are singletons by default, but you can have them so that they're on a per object base or per thread basis. There's a number of ways that you can actually control that. Okay, so you have the flexibility to be able to work around concurrency issues. Can you use it to secure session management? Another excellent, everyone's asking excellent questions. Yes. Suppose you don't have secure session management. Even authentication, right? The application doesn't have these controls. You can wrap it so that any call that comes into your application, you make sure that you have an authenticated principal, and that authenticated principal has a valid session. And if they don't, then you send them to the authentication page. You redirect them. Any other ideas? What about logging and monitoring? Sorry, did someone say something? Excellent, logging and monitoring. Okay, he still gets a chocolate. Logging and monitoring, right? Logging. It can instantly log every performance or every time that a certain method is executed, before it starts, after it ends. Exception handling, I think we talked about briefly, right? So basically all of those security controls that we think of, in many cases, we can throw into aspects. Now, someone brought up a good point that certain cases, like specific exception handling or very specific logging, you might want to still keep in the source code. But we can try and get a lot of it out of our methods. And what that means is we can function or concentrate on functional requirements, right? On actual core business logic, and take out all these other things and throw them into aspects. So we're going to get a lot of objections. I've seen a lot of objections. I wrote an article about this for Security Focus, and I got about 6 comments that said the same thing. Listen, we can do this already. OOP already does this. People are just trying to reinvent the wheel and, grab a lot of credit for it. And, okay, fair enough. You can do anything with OOP. But just remember, before OOP, you could do everything that you can after OOP, right? Many of our operating systems are written in C, not C++. But that doesn't mean that C++ doesn't afford us better design. And that's the idea behind AOP. So let's think of this. 10,000 objects, okay, massive application. They don't necessarily have anything in common except they execute this method 1, all right? And they all do business logic. Then things evolve. We realize we need to put authorization checks on every instance of that method 1. So we do, 10,000 times. This is what, in the AOP world, they call code scattering. Okay, these are concepts that go outside of what's supposed to be done for the business logic. So things like transaction management, a lot of security concerns, logging and monitoring, a lot of exception handling. It pollutes the code base. And there's actually been statistical correlation between the amount of pollution that's in there and the number of defects we have in our code. So the idea is this. If we took it out, right, we could focus specifically on just the do work part. Now, again, let's assume we have this, and then later on we decide we want to add transaction management. Well, 10,000 times we have to do the start transaction. Okay? So hopefully you're starting to see here that even if it's not solving a new problem, it's a different way of solving existing problems. Right? We can take all of this out and have one aspect to handle it all. Right? And just imagine how much cleaner our code is and how much better we can modularize it. And it gets to the idea of coding securely versus coding security, right? We still want people to code securely. We don't want them to break, to give you cross-site scripting vulnerabilities in the application. But what we can do is we can take a lot of the responsibility for security functions like access control, like session management, like exception handling, like input validation, and give it to a few core people who understand it really well, right? And that's where the true power comes in. The next one is AOP is unproven and unstable. I got this a lot, actually. Some stupid technology, no one knows how to use it. We can do other things like servlet filters. Yeah, you can do servlet filters in the presentation tier, but you can't do them anywhere else. AOP has been around for 11 years. Aspect-J has been around for 11 years. It's an official Eclipse project. AOP is now available in Spring, right? If anyone's familiar with the Spring project, Spring framework, it's available in JBoss inherently, and it's going to be available in WebSphere and WebLogic. And in fact, some parts of WebSphere inside the actual development uses AOP concepts. We're going to get to that actually, but excellent point. .NET as well, right now. AOP is unproven and unstable. Well, IBM has said AOP is vital for our survival. Microsoft, actually, we just found out today Microsoft is no longer researching AOP for .NET. It's actually available for Visual Studio 2005 for C#, okay, from Microsoft itself. There have been third-party add-ins before, but now Microsoft themselves are creating it.
No, it's called Aspect AOP for .NET.
AOP for .NET?
Yeah.
Are there multiple kinds?
There are multiple kinds of them, but Microsoft has primarily brought this out for C#. They've not yet brought it out for the other ones. There are some that are, and I don't want to jump ahead into it, but we'll talk a little bit about it in a few slides for sure.
Industry. So at the last two aspect-oriented conferences, Siemens, Hitachi, SAP, and Motorola presented cases where they were using it in their applications. Okay, so it is being used in the real world. This is not just theoretical fluff anymore. Performance overhead. Going back to the original question. Okay, there's two ways of doing AOP. One is doing it at runtime, like what the Spring framework does. It doesn't change the way that we compile code. Well, then that becomes an issue because we actually start looking at methods and we look for, at runtime, what's the signature of the method, what are the parameters of the method, and that adds a lot of overhead. Okay? So that is something that is legitimate concern. But when we go to compile time weaving, which is what Aspect-J does, remember our set name example? Well, in set name, what would have happened is in the bytecode for set name, before it actually executed, it would have pointed over to our aspect. And so that was a one-time, quick, not major performance hit, right? And there have been benchmarking studies on that as well. Any other objections you can think of? Reasons why this is not a good technology to use or no one would actually use it? You absolutely can. But that's not necessarily a bad thing. Yes, you can inject code that can cause harm. You're right. That's worth it. You can inject code that causes harm, but that's there. This is the point, is that it's already there, that functionality we can already do. But you can inject that code only if you can change the source code. Right? And if you can change the source code, you can do a hell of a lot of dangerous things. So there's a trade-off here. Yeah, you have some element of danger with AOP, but when we think about like our web app deployments, the security trade-off that we get is a lot better from what we can protect against versus the changes that we can make in a malicious manner. Although it's great for pen testing, which we'll get to later.
I would also submit there's a danger inherent
Okay?
in increased complexity for debugging or trying to track things that are something's breaking, we're trying to figure out where it's trying to go through. Something's happening between here and there.
And you don't know what's going on. Excellent question. Very real concern. A lot of actual effort has gone from the AOP community to create visualization tools and debugging tools that will actually help us to determine when that happens. Okay, so there's sophisticated tool sets to help us with that. And what people have done it before have said that it's actually easier to debug than it is on a regular OOP application.
The cost of modifying your process to support either AOP, hiring developers that know it, and or like let's say modifying like a complex spigot inspection process to like a new process that moves this.
So changing our existing processes and the objections that go with that. Yeah, absolutely. That's real. That's a real one that's not easy to change. So we're going to suggest some adoption strategies. Basically, it comes to phased implementation, starting in the lab, then starting with really non-critical functions. And you saw how easy it was, right? You looked at it. It is that easy. It's not a sophisticated skill set to do some of the very simple things. Okay, so we'll revisit that after, but good question.
I know that's straightforward to write this aspect. Sometimes we look at a very simple example of implementation, for instance, syntactic checking. Implementation might involve a lot of semantic information. You need to get other information from within your program to be able to determine whether the data is valid.
That's true. It's not necessarily always as straightforward. Although that was a real application, it's not always that straightforward. That's true, but if the same people who are developing your applications are the one who are developing your aspects, they know it best. So again, any control that you put in place is going to have that complexity inherent in it.
Well, how do these visualization tools work if you've got layered aspects? You've got a layered aspect, aspect J,
Yes.
and then you're running on Spring and you get the layered aspect.
Okay, if you're using Spring and Aspect J separately, then you're in real trouble. But if you're using, let's say, multiple aspects, right? If you're getting at the point of multiple aspects that may function on the same method, no?
See, the thing is, Spring doesn't give you full AOP, but there's a lot of benefits that Spring has. Therefore, you may want to do your aspects in Aspect J, and there's portions of Spring that are going to use aspects no matter what.
Right.
You get aspects coming from both places.
So what you find is actually in Spring specifically, or Aspect J, there's support, and in fact you have to do this as part of your process, is prioritization of aspects. Okay, so you can actually say which aspect comes first before the others.
Are those visual tools going to give you insight into both layers of aspects?
Are they going to tell you which aspect occurred at one time? Yes, if you're doing it during debugging.
Do we see the Aspect J aspects as well as the Spring aspects?
The Spring aspects might be a little different. I'm not entirely sure about how it affects with the Spring aspects. I know with Aspect J it can tell you which aspect is occurring, but I have to look into that.
How does it interfere, or how does it work with already built-in input validation or logic? If you're kind of capturing something that a particular function maybe was trying to implement, maybe not correctly.
Yeah.
How does that work?
Well, it would be like, I guess, anywhere where you do more than one level of input validation, in the sense that it might pass one and fail the other. You do have to know what's happening in your application. So you may, for instance, allow something through here, and it might get denied by the rest of your input validation or vice versa. But the idea behind this is you do usually have some level of input validation. So that's a very real scenario. You just want to add to what's already there, right? Again, it takes you on. It's not like you can't know what's happening in the application. You do need to know that.
How does it affect the coding complexity metrics like stuff like that?
So it depends on how much you actually implement. But once you start to, like a real true AOP implementation, really helps actually your metrics because the complexity, and you can see that looking at it, right? The complexity goes down dramatically. And so the studies have shown that the number of cross-cutting concerns or the number of weaving of cross-cutting concerns goes down, and you actually modularize your code better. The cleaner the code is, the less complex it is, and the less defects you have. Okay, but that's probably we're a ways away from that. I'll take one last question because we have to move on.
Beyond input validation, can it help you prevent against SQL injection?
That's a great question. We're going to show you a video, so I'm not going to answer that right now. In fact, we will answer it right now with a video.
Okay, we are back to our Daffodil application over here, and now we are looking at actually inside the code. The class that we are looking at is, actually I can't see the class name. It's excelcreator.java. This is a class that actually allows you to create Excel sheets inside CRM, and you can actually export all your contacts inside CRM itself. So imagine, if you will, a scenario where you're doing source code review of this application and you're walking through it, and that's what we are trying to do over here. We go through the application and we start noticing that there are multiple queries that are taking place, at different parts of the code itself. We are seeing the queries that are taking place, and right over here, can you magnify it? Maybe it'll make it easier. No, it just magnify. Just start the magnifier. Hang on one second. I'm just going to try to magnify it.
So this is export Excel. This is, like we said, a function to actually create Excel. And one of the things that happens in Daffodil is they use dynamic queries everywhere. Okay, so what we want to show you is some dynamic SQL happening. So
I guess it's not here. Anyways. Sorry, the code is a little small, but we'll try to talk to it. Basically, behind the scenes, what we saw over here, a little further back, there we go. What we are seeing over here is a simple statement trying to execute a query. And if you look at it, it says, let me go closer, that way I can read it out. Execute query info, which is a string inside execute query, which is coming in through statement.execute query with a string inside. What do you think can happen when you have execute query? What could it lead to?
execute query with the string.
Execute query with a string, correct. It would lead to possibly injection. It is possibly, more than likely, a dynamic SQL that is being created. So what we are going to try to do is actually use an aspect to figure out every single occurrence of dynamic SQL that is inside our entire piece of code base. What we have here is some pieces of code. I'll try to point to it so that way you guys can follow along. Right over here we have java.sql.statement.execute star, and in front of statement you see a plus sign. What it says is, whenever the statement class or subclass is called, look at this aspect and try to look at what is happening next. Then we have execute star. Execute star could mean anything. Execute query, execute update, whatever have you. And the first argument is a string. Okay. So the first argument of that execute star should be a string. Whenever you have the first argument as a string, it always leads to dynamic SQL behind the scene. What we are trying to do is create a log file with every occurrence of dynamic SQL. That's what we are trying to create. actually map it out. Okay, here we go. We'll actually map it out. If you notice over here, we have statement. Oops. Sorry, can you go back a little bit? Yeah. So over here we have statement.execute query. Remember we said execute star. Whenever there is execute star, it should come down this path. So it's going to come down this path and it will say, okay, statement, where is statement? It is con.create statement. Remember again, we said statement plus. So whenever there is a subclass, in this case the subclass statement is being executed and an execute method is being executed, so it is going to actually call this piece of code. Okay, let's go back to our dynamic SQL. Here we actually see that when this is called, what should happen? Well, before that, we are going to actually use log4j to actually write that into a log file. Okay, as simple as that. We're going to say dynamic SQL in, and then there is this syntax. Forget about the syntax for now. The syntax is going to say what line number, what class is actually being called. So let's go ahead and click play and now see this in action itself. So here we are going to load up Daffodil CRM, but as we are doing it, first we are also going to show you the log file that it is going to write to is completely empty. Right? And here we log in with very secure password, admin, log in into the system, and then look on the right hand side, there is an export feature. We are going to click it, and of course CRM is very secure. It's prompting us for password again, transaction based authentication, and it actually tries to push the Excel file to us. Note, whenever this Excel file is pushed down to us, we know that that piece of code has been executed. Let's go back to our log file and see what has happened. You can see that actually it is written warning dynamic SQL in class, line number 107. Let's go ahead and look at line number 107 in our piece of code. So we're going to go ahead and open Eclipse. Again, go to our line number 107 and try to see what is on line number 107. Over here we are on line number 84. We are going to page down a few lines. And look, line number 107 actually does not have anything. It is commented out. What's going on over here? Is that program wrong? Well, let's go back to our log file and look at what it is saying. The other thing it said was execute Excel creator and not which file are we in? Export Excel.java. So what we are going to do is we thought that primarily the call was coming in from a different file. But Excel Creator is the one that is calling line number 7 where the actual SQL, dynamic SQL is being executed. Okay? So though we thought that originally the vulnerability was in a different file that was export Excel, behind the scenes Excel Creator was the one which is calling the dynamic SQL. Now with Aspect, we did two things. One, we have created this generic template. Now you can actually use with all your pieces of code, just add this in and it's going to look at every single occurrence of dynamic SQL, what line number, and you can do the analysis. Okay. And what is actually calling it? You can see that as well. Now you can come back to me and say, well, that's fine and dandy. Could I not just, unjar the file or unzip the file and then run jar on it and grep for it and do the same thing? Yes, you can, but here this is so much faster and you can actually see it at runtime which ones you need to work on fixing rather than fixing every single thing. As you all know, I'm sure you have encountered that you'll have hundreds of bugs or hundreds of applications with a few bugs in each of them, and how do you fix every single bug? This would be one of the easiest ways to figure out which is higher priority as opposed to just fixing everything.
And
Any questions on this?
Just before that, one major key that Nish had pointed out is when you run an application, you might be importing a whole bunch of libraries, and you might not know what's going on in those libraries, right? There are a whole bunch of jar files, and they might be executing dynamic SQL, and you have no idea. So this is a great way for you to actually see what's happening.
Yeah.
That's like you were talking that you could see it at runtime. Is there any way to see it at runtime outside of Eclipse, like with like a different debugger or with a different on the server side? Like, what's the easiest way to go about doing that?
So Eclipse is, this is just an IDE, right? You can use any application server and use AspectJ, and so we could be running WebSphere or WebLogic, and it'd be writing to a log file. So what we're doing here is we're checking a log file, but we could print a console if we wanted to. We could import it into a database if we wanted to. We could do whatever we want. We have that flexibility with Aspects.
Yeah.
Do you see this concept more as something for going in and patching legacy code, or is this a concept you integrate into designing an application from the bottom up?
That's an excellent question. So we would like to see it from kind of the bottom-up scenario. Most people kind of take offense to the idea that they can't create the application themselves properly with OOP. That's kind of where we are right now. I think in the industry we're not having a lot of people create it from the ground up, but it makes a lot of sense to create it that way. With legacy code, it's really hard to change a lot of times existing code. So this way we can do it and we can take it out very easily. That's kind of where the business case comes from. It's a little annoying.
Okay. Okay. I guess some of the other things that we'll talk about are AspectJ. Well, as Rohit was mentioning, AspectJ has been around for 11 years and is one of the most popular, actually it is the most popular AOP implementation in Java. AOP.NET, I think someone was talking about .NET, I think you were talking about .NET. AOP.NET is trying to implement, or it has implemented, the same style of weaving technique in C# by Microsoft. Now, of course, there are techniques like that are used with Spring AOP, which is the proxy-based approach. The same technique has been used inside .NET by other implementers, but nothing like what Microsoft is doing, which is pretty interesting. It has been actually led by a professor out in Russia that started all this effort, and it is something that I would recommend looking at for sure. And then there is Aspect-C, C++ available as well. What do you guys think we could do with Aspect-C, C++?
Stop all buffer overflows.
Whoa! You guys really think we could stop all buffer overflows with that? Well, think about it. I mean, you can, at least for our security friends who are researchers, could actually start doing fuzzing on one side, and with aspects, every time there is an occurrence of star copy, star length, with values inside it, write to a flat file or a log file somewhere, right? Now suddenly, instead of always having a runtime environment, having a debugger attached to it, and what have you, and constantly monitoring to figure out the stack, it would be much easier. It would be much easier if we did it just with aspects, right?
Please close the door. Thank you. Okay, it's not going to happen. So aspects, another thing that we can think of is from a defense standpoint for buffer overflow. Think about all the times where we have functions that don't check the length of the input coming in, right? That is a fundamental cause of a lot of our buffer overflow issues. Well, now we can create aspects to check the length before the function actually executes. All right? So maybe not stop all buffer overflows, but certainly go a long way to securing a lot of legacy apps that didn't have those controls built in the first place.
I would like to add a caveat that this is something that we are starting to research on. We have not yet done hands-on a lot of research. Hopefully we'll be releasing some papers or talking about that as well soon. But that is something of interest that you guys can try out as well. AOP, C, C++.
Yeah, we'll be having a few talks on that. Sorry, let me just do one more slide and then we'll take up any questions. So adoption obstacles, I think we talked about. Lack of skill sets not there. untested technology in a lot of people's organizations, and change to development methodology. These are all things that we need to go over, right? So what we can do is we can start in the lab. We don't need to throw these into production right away. We can see how it works in the lab. We can build our skill set that way. And then do an incremental production implementation. Okay? Don't just do everything at one time. Start with something that's non-critical, like logging every time someone hits a help function or something along those lines. And now we can take any questions for about 2 minutes.
Sure.
So for the binary, the C++ stuff, is there going to do it on binary, like in assembler or C or like any language?
There is at the binary level that you can do it as well with AspectJ. In fact, even with .NET, you can do it at MSIL level.
You're saying any compiled assembler.
Oh, I don't know. I'm not.
That's a good question. I haven't seen that, but that's entirely possible.
Any other questions? Thank you, everyone. Thank you. Here you go, buddy. Thank you.
All right, how are you doing? I'm looking forward to this.
Yeah, Mike. Sorry?
Never mind.
What's that?
Nothing.